Instantaneous velocity is velocity within a given time. A given time. The word instant means time. So instantaneous velocity, velocity within a given time. So maybe this is T1, this is T2, then this is T3, meaning we are determining the velocity, okay, within the time T3. Now, how do we do this? We do this by drawing a tangent to the curve. There's a tangent through the time that is required. Maybe find the velocity within, determine velocity within a time T3. We are using our time axis, okay, in terms of T's. So we are asked to determine the velocity within a time T3. So it means that it is change in this vertical, which is delta S, over the change in the horizontal, delta T. So the velocity at time T3 is equal to change in S over change in T. And change in S is equal to this value of displacement over here. Let's take this to be maybe S2. So S2 minus 0 divided by T3 minus T2. Okay, so this is how to calculate for instantaneous velocity on a non-uniform velocity motion. It is non-uniform because it's not a straight line. You can't get the velocity or the slope to be uniform. That is why it is termed as non-uniform velocity motion. Now, on a non-uniform velocity motion, when you find the slope, okay, can be either increasing or decreasing. So on a non-uniform velocity motion, the slope for this particular illustration, the slope would increase at every given time. The slope increases at every given time. Now, for any displacement time graph, the slope is equal to the what? For any displacement time graph, the slope is equal to what? Yes, class.
Velocity.
For any displacement time graph or distance time graph, the slope is equal to
Velocity.
Good. So if the slope increases at every given time, it means that at a time t is equal to 2 t3, what you determine as the slope must be less than what you determine as the slope for time t3. So t3, the slope of t3 will be greater than slope of t2. The slope of t4 will be greater than t3. Amelda, your hand is up.
Sir, please, did you subtract T2 from T3 because the tangent passes through T2?
Yes, because the tangent passes through t2. If it passes through t1, I would have subtracted t1 from t3. Okay. All right. So t2 will be greater than, the slope at t2 will be greater than t1. The slope at t3 will be greater than t2. The slope at t4 will be greater. So if the slope is increasing, then it means the velocity is increasing with time. Now, if the velocity is increasing with time, what can we say about the body? Class, if the velocity increases with time, which is the slope, then what can we say about the body? Anybody to share what he or she thinks with that? Emelda.
I think if it's increasing, the body is increasing in its speed.
So yes, it's true. We realize that at every given time, as the time increases, the slope is increasing. And if the slope is increasing with time, it means the velocity is increasing with time. Now, if you have a body whose velocity increases with time, how will you describe the motion? Yes, Sidel.
Sir, please, the body is accelerating.
The body is accelerating. So on a non-uniform velocity motion, the body accelerates. So apart from this, is one thing you can deduce from a non-uniform velocity motion. One, that you can determine the instantaneous velocity. Then you can also identify or deduce that a body exhibiting such motion also accelerates. The body is accelerating because the distance covered increases with time. Now, if the distance covered decreases with time, then the body would also decelerate. So whenever, for a non-uniform velocity motion, whether the displacement is increasing or decreasing with that in that non-uniform pattern, the body either accelerates or decelerates. Please, any question? Okay. Then the last grouping of the graph, then we move on to a different thing. I have this graph. And it's a velocity time graph. Class, the motion is such that it starts from the origin Now this point, okay, I'll label it later. Then gets to this point. Then the body finally this is T1. This is T2. This is T3. And finally, this point is T4. Class, I want you to describe this motion for me. Let's connect these two. Maybe V1 Let's connect to V2. I want somebody to describe this motion for me. Yes, anybody? Anybody who can see clearly to see what I'm seeing? Yes, anybody? Oh, hello, are you there?
Please come again.
I want somebody to describe the motion on the screen for me. Yes, Imelda, break the ice for us.
Means the whole thing or just the T1 and the V1?
Everything.
So I
I've
think
served a meal, so everything, eat everything.
I think it means the body starts moving with a constant speed, then accelerates, moves with a constant speed, then comes back to a starting point. And ends at a certain point.
Imelda,
That's how.
you are giving me a summary. What's a summary? Okay, let's hear from somebody else. Who else is ready to try? Please, if your hand is up, go ahead.
The body accelerates from 0 to T1, maintains a constant speed to T2, accelerates to T3, and decelerates to T4.
That is Frank's summary. Do I have somebody else to share what he or she also thinks? Benjamin. Benjamin, I'm listening. We are listening. Hey, Benjamin, is it network or you are still engaging your brain? Oh, okay. Kasua, go ahead. Oh, what is happening? Class, can you hear me?
Please.
Kasua. Okay, let me take over. You see, Oh, Kasu, unfortunately, your line is breaking. Okay, let me take it up. You see, the motion.
Sir, please, the object accelerates to T1 at a velocity.
Okay, that's why. Please, your network. Okay, so let me take over. Let me take over. Okay, so what it means is that the motion is starting with an initial velocity of 0. So initial velocity is equal to 0. And class, when a body is in motion and the initial velocity is equal to 0, we term the motion as the body starts from rest. The body starts from rest. So a body starts from rest, accelerates uniformly to a final velocity v1 within a time interval of t1. So the body starts from rest and accelerates uniformly to v1, but you must talk about the time within a time interval of t1. Then maintains a constant velocity from t1 to t2. So within this time interval, t1 to t2, the velocity is the same, maintains a constant velocity. So, and the velocity time graph, when the slope is 0, it means constant speed or velocity. Okay, and maintains a constant velocity from t1 to t2 and accelerates uniformly, okay, to v2 within the time interval t2 to t3. So it accelerates uniformly. Then from there, decelerates uniformly. Then decelerates uniformly to rest. To rest, to rest. Because the body is ending with a final velocity equal to 0. So it decelerates uniformly to rest. Here is an acceleration because it's a positive slope. And as I said earlier, when the slope is positive, it's an acceleration. Here, the slope is 0. So the body's velocity is uniform or constant. Between T2 to T3, the body accelerates again. So you can also calculate for the acceleration. Then from T3 to T4, the body decelerates uniformly to rest or to a stop. This is the motion. Please, any question? Now, assuming this is point, I'll say, fine.
Sir, please, whenever you're explaining, is it very important to add uniformly to the accelerating and decelerating?
The body, you see, along OA, I'm adding the body accelerates uniformly because no matter the point chosen, the 2 point chosen to determine the slope, you must have the same value. So OA is a uniformly accelerated motion. just as BC is. The reason for which you must add, the body accelerates uniformly, because it's a uniformly accelerated motion or uniformly decelerated motion. So Frank, yes, you must bring it. Okay.
Okay, sir.
We can calculate for the acceleration from O to A. And don't forget, the slope of a velocity time graph is equal to the acceleration. So if we find the slope of OA, it gives us the acceleration from O, that uniform acceleration I talked about, from O to A. When you find the slope of BC, you also would have the acceleration of BC. So determining the slope at every point gives you the acceleration. If you find the slope CD, which is the whole of this, change in the vertical against the change in horizontal, you determine the deceleration, the uniform deceleration. Okay. Then when you find the total area under the velocity time graph, the total area under the velocity time graph, you have the total distance covered, or the total distance covered. So you see, because this shape cannot be described as to just one entity, in finding the total distance, you can segment it into shape. OAT1 is a triangle. So maybe one, you segment this as one, find this area. ABT2 T1 is a rectangle, 2. Then BC T3 T2 is a trapezium, 3. And CD T3 is another triangle, 4. So you find the area of this triangle, area of this rectangle, area of this trapezium, area of this triangle, and then add to get the total distance traveled by the body. Class, is that okay?
Yes, sir.
I'm hinting on this because, in fact, I will send you a question to work on this, and I'm going to, pick questions on all that I've taught today. So please, if you have any question, ask. Any question? So if you want the acceleration, the uniformly accelerated from O to A, find a slope, because the slope of a velocity time graph will give you the acceleration. Here, the acceleration is 0. So the slope is, because the slope is 0, acceleration 2 is 0. If you want the uniformly acceleration from B to C, find a slope. If you want the uniformly deceleration from C to D, find a slope. However, if you have to find the total distance from O during the whole motion, find the area under the velocity time graph. Okay. If the area is a triangle, area of a triangle will give you the distance traveled. If the area is a rectangle, area of a rectangle would give you the total distance. If it is not a definite shape, which then divide it into parts, okay, using the shape, and after doing so, sum up all the areas obtained. The total area under the curve is equal to the total distance traveled by the body. No question. I have run.
Sir, please, can they ask you to find average velocity from the diagram if they've given you values?
Yes. You can be asked to find average velocity. I earlier said that average velocity is the effective velocity. And average velocity is equal to total distance traveled divided by the total time taken. So you can determine the average velocity after determining the total distance. Okay. The total time taken would obviously be T4. So after going through what I earlier gave you, then you can use it to determine the effective velocity during the whole motion. Is that clear?
Yes, sir. Sir,
Okay.
but what about the time taken? That one, how you do it?
Oh, the total time taken. Assuming this is 2 seconds. Like assuming the change in velocity occurs in one equal intervals of time. So 1, 2, 3, 4. Then it means that the total time taken during the whole journey or distance is equal to 4 seconds. So your total distance divided by that. Are you okay?
Yes, please.
I'll give you a related question so that you try your Emelda. Emelda, go ahead. Hey, Emelda cannot hear me. Maybe network. Okay. So the next Emelda.
At the
Hey. Emelda, I'm listening.
what about the total distance?
Oh, the total distance, that is what I've explained. Sorry. That is what I've explained. That if the graph is just this, V, T, and you have this graph, the motion is like this. Then, once it's a velocity time graph, the area under the velocity time graph is equal to the total distance. The whole area. So let's assume that this is this is 2. Then this is 6. So 2 seconds interval. So this is 2, that meaning this is 0, this is 4, and this is 6. Now this velocity is maybe 10 meter per second. Meter per second. Meaning our time axis must be in seconds. And I'm to calculate for the total distance traveled. What I'll do is that either, what is this shape? What is this shape here? The whole shape. I mean the whole shape.
Trapezium.
It's a trapezium. So I can
Yes,
determine
sir.
the total distance traveled using the area of a trapezium, half A plus B times the height. Now what is A? A is the two, A and B are the two parallel sides. So A is the shortest, B is the longer out of. So from what we have on the board, what's the value of A? Yes, can somebody help me deduce the value of A? from what we have on the board. What's the value of A?
4.
Let's hurry up. Frank. That is 4.
4.
4 plus, what is B? What is B? 6. H is the vertical height perpendicular to both of them. So this is H. So from the graph, the value of H is 10. So we have, this is 10 times 5. So the total distance covered is 50 meters. This, I can also divide this whole area or shape into 2. This is 1, and the whole of this is 2. So the first one is the area of a triangle, which is half times the base. The base of the triangle is 2. Then the height of the triangle is 10, giving us 10 meters as this area. Then the next shape is a rectangle. Area of a rectangle, length times breadth. The length here is equal to 10 times 4. This is giving us 40. Therefore, total distance is equal to the area of the triangle, which gave us 10, plus the area of the rectangle, which is 40, totaling 50. So we are getting the same value as when we had taken it as one area. Trapezium. Class, are you okay?
Yes, please.
Yes.
So that is what I said here. You see, looking at this shape, you can't identify this to be a single shape. I don't know if it's a trapezium or quadripedium, right? So the best way out is to divide it into different shapes. 1, which is a triangle, 2, rectangle, 3, a trapezium, 4, a triangle. So if you have a shape and it is not well defined or it's not clear, that is how you must do to determine the total distance covered. Plus, are we fine?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Any question?
Yes, sir.
All right. Any question? No question.
No.
If no question, then I'll draw the curtains here and then send you a very beautiful work set to engage you during the weekend. Okay, look through it, apply all the techniques, watch the video, and answer it for me. I'll actually put the deadline, everything. Let me commend you on the first assignment I gave. In fact, a lot of you, almost all of you, were able to do something and present. Keep it up. Let's work hard. And in fact, physics will definitely be interesting. Until next week, may the good Lord be with you, take care of you, and then give you retentive memory. Until then, in fact, bye-bye.
Bye.
All right. Good night to all of you.
Night.
Bye.
Same to you.
He's gone.
I'm gone. I'm gone.